Now that we have installed the software and the needed libraries, we will create the IEEE 9 bus of figure 1 in the modeling companion. Click on the New Model button in the toolbar to create a model file. Name the model, for instance, IEEE 9 bus. Note that there should not be any spaces in the name of the model. Specialization should be set to model and press OK. You will be directed to the model design area. If your OM screen does not look like this, you can easily change your view. This is the graphic modeling view. This is the equations view, and this is the documentation. This interface will now be referred to as Network Model Workspace. Now that we have created a new project, we need to load components from the library. The OpenIPSL library has models of components that are validated against various power systems simulator softwares like PSSE, PSAT, etc. Here we use models that are validated against PSAT. The main components to be used for creating the 9-bus network are bus, which can be found in OpenIPSL, electrical, buses, and bus. Similarly, generators can be found at OpenIPSL, machines, PSAT, and then the machines are listed here. Loads, lines, and transformers can be found in a similar way. Using the components mentioned above, create a 9-bus network, but without creating the generators yet. The data for the system will be filled in later. You can simply drag and drop components to the network model workspace to create the network. We have already created a sample of the 9-bus system, which we are going to load here to save time. The 9-bus system should look like this. The components should be named in a particular fashion. It is very crucial to follow this rule. For single terminal element, name of the element followed by bus it is connected to. For example, generator 1 should be named Gen 1. For two terminal elements, use the element name followed by terminal numbers separated by an underscore. For example, a line may be named as line 1, 2. The usefulness of naming your components in such a way will be seen soon. Also, be careful. A transformer should be connected from low voltage side to the high voltage side. The sending bus voltage must always correspond to low voltage side. Transformer ratios can be entered as V1 by V2 instead of calculating the decimal values. The model you created must include a system base card. This is found at OpenIPSL, electrical, system base. Drag the component into the network workspace and name it as sysdata. This component sets the frequency and base MVA for the system. Now, to model the generators, we use the following philosophy. The one way to model generators is to simply drag and drop the machines onto the network area workspace. This technique works best if there are no additional components to be added alongside the generator, such as an AVR, PSS, governor, and so forth. If controllers are to be added, they will take up space on the network model workspace as well, crowding the entire model. The best way to overcome this is to create a separate model file that can represent a generator and all of its associated dynamic models, and then import this model file into the network model workspace. To do this, start by creating a new model file and name it gen. This new gen.mo file will now be referred to as generator model workspace. Drag the model order4 generator from the OpenIPSL library and name it such as Sin1. Connect the VF0 to VF and PM0 to PM. This model needs to interact with the outside world via an electrical pin. Drag the component PW pin from OpenIPSL interfaces PW pin to the generator workspace. Name it as P. Connect the generator's pin to this newly created pin. This model can also be given an icon. Go to the icon mode and use the tools provided by OpenModelica to create your own icon. Save the model. This can now be seen next to the libraries in the Libraries tab as generator. Finally, one of the key features in Modelica is model reuse. Currently, if you drag the generator model into the network model workspace, you can connect the generator to the network, but you still cannot set any parameters for the machine by double-clicking it. To get access to all the machine parameters, we need to make changes to the generator model. Start by opening the generator model and switching to the equations mode. Copy the code block 1 from the companion before the equations section. To save time, we have already created a generator model that we will use here. Now in the diagram mode, open the machine model. And in the machine parameters, fill in the text next to the machine parameters name exactly similar. Press OK. The machine model should look like this. Follow the same convention for the Power Flow Data tab of the machine. Press OK and save the model. Now, drag this generator model to the 9-bus area, 9-bus network workspace, and you can see that you can connect these generators to the 9-bus system that you created. Now, when you open the Gen 1 model from your network model workspace, it will show you the parameters of the machines that you can set. Now connect the generator 1 to bus 1 using the same method. Create 2 more generator model instances in the network model workspace and then name them Gen 2 and Gen 3. Connect them respectively to bus 2 and bus 3. In the end, the model should look like this. In the next video, we will initialize and run our simulation.